Okay, so this is the key to the worksheet on factoring called Factoring 1. And in number 1, you want to find the GCF of the following list of terms. And so notice you have 1, 2, 3, 4 terms. All right, so if you look at those 4 terms, first of all, you need to look at the coefficients. And they're all 1. See, that's a 1, that's a 1, that's a 1, and that's a 1 here. So in terms of the coefficients, the GCF is going to be 1. Okay? Now, let's talk about the variables. So let's look at your variables. If you notice that all of these 4 terms have factors of x in all of them. So you're going to need some factor of x here. You have factors of y in all of them. So you need some y's here. The question is, how many do you need? How many factors of x will be part of your GCF? Well, remember, when looking at variables, the GCF will be, for the variable, will be the one with the smallest exponent. So if you look at the x's, I have 10 factors of x here, because remember, x to the 10th means x times x times x times x 10 times. So you have 10 factors of x. So the exponent tells you how many factors of this x you have there. And then here there are 9 factors of x, and here there's 1 factor of x, and then here there are 4 factors of x, so you're going to use the smallest exponent, the one with the smallest exponent. So you're going to have 1 times x so far. Then if you look at the y's, I have 10 factors of y, 9 factors of y, 10 factors of y, and 5. And so the smallest number of factors you're going to need for the GCF will be y to the 5th. And so in number 1, the answer will be just x, y to the 5th. Okay? So number 1, the answer is x, y to the 5th. Okay, let's look at number 2. Number 2, we have these 2 terms. We have 64a to the 8th b squared, and the other term is 4a to the 6th b to the 8th. All right, so that's an 8 here. So look at the coefficients first. That's a 64 and 40. 64 and 40. And the way you need to think about that is first of all, what are the factors of 64 and what are the factors of 40? So if you look at the factors of 64, and remember we're looking at factors here, factors of 64, we know that 1 times 64 is 64, so 1's a factor, 64 is a factor. We know that 2 times, let me do this, so 1 times 64 is 64. We know that 2 times 32 is 64, right? So 2 is a factor, and 32 is a factor of 64, so you're just listing your factors. And then just all you're doing is just thinking of products, and use your calculator if you need to. So find 2 numbers whose product is 64, and so those would be factors. And so let's try, 3 is not a factor, so let's try 4. So, because look, 64 divided by 4 gives you 16. So 4 times 16 is 64. So that means 4 is a factor and 16 is a factor. Then you keep trying. So 5 was not going to divide into 64, nor will 6, nor will 7, but 8 will, right? And you can tell that because look, if you look at 16 and if you look at 32 even, will 8 go into 16? Sure it will. So therefore 8 is going to be a factor of 64 as well. Now 8 times what? 64. Well, if you don't remember it's 8, just say 64 divided by 8 and you get 8. So 8 times 8 is 64. So we're going to list it here. We only list it once though. And then you keep on going. So I think we may have indicated all of. We have 16, we have 8, we have 4, and let's see. Yeah, I think, okay, so we've listed all of them. So those are the factors of 64. Now you do the same thing for 40. So you list the factors of 40. So 1 times 40 is 40. So that means 1's a factor of 40, 40 is a factor of 40. Then you say 2 times 20 is 40. 2 is a factor of 40, 20 is a factor of 40. And then 3 won't go into 40 evenly, but 4 will. 4 times 10 is 40. And basically you just kind of look at these as well. So if you look at 20, 4 goes into 20, right? So that means I can use, so that means 4 is a factor of 40 as well. So 4 times 10 is 40. So I'm going to list 4, I'm going to list 10. And now notice the 10, notice the 20, notice the 40. Will 5 go into all of those? Sure it will. So 5 times 8 is also 40. So 5 is a factor and 8 is a factor. And I think we may have indicated all of them. And so if you look at all of your factors here, you want the one that they have in common. That's the largest. Now be careful. They have 2 in common. So they have a common factor, but it's not the greatest. 1's a common factor. 2 is a common factor. And then 8's a common factor, right? So the largest would be 8. So the GCF of 64 and 40 is 8. So what that means so far is that the GCF of those two terms in terms of the coefficient is going to be 8. Now the variables, most students don't have an issue with that because remember you always pick the one with the smallest exponent. So I have 8 factors of 8 here, 6 factors of 8 here. So you're going to choose 6 of them. And then here I have 2 factors of b, 8 factors of b, so I'm going to pick 2 of them. So the GCF will be two of those factors. And so therefore the answer for number 2 then would be 8 to the 6 b squared. Okay, now in number 3 you want to factor out the GCF. And so at this point remember, it helps if you use the distributive property to check your work. So we have 15x to the 7th minus 9x squared plus 21x. And so if you look at 15, negative 9, and 21, at this point you need to recognize that the GCF of 15, negative 9, and 21 will be 3. So far my GCF is 3. Now look at the variables. I have x's in all terms. I have 7 factors here, 2 factors here, and only 1 here. So I'm just going to use one of them. So that's your GCF. And so now you're going to factor out that GCF. All right. So remember, factor out does not mean just indicate the GCF. You gotta factor. So you're factoring out the GCF. And all you're doing is using the distributive property to get this back. So 3 times 5 is 15. X times x to the 6 is x to the 7, because remember, you multiply like bases, you add exponents. 1 plus 6 is 7. Minus, and then 3 times a negative 3 is a negative 9. X times x is x squared. And then plus 3 times 7 is 21. And see, you only had 1 here, right? You already factored it out, so you don't need any more there. And so that will be the answer for number 3. So number 3, you have 3x times 5x to the 6 minus 3x plus 7. All right. And then number 4, you want to factor by grouping. So let's look at that one. So we have 4x to the 4th plus 5x cubed plus 4x squared plus 5x. And usually, it's not always true though, but usually you're going to try grouping the first 2 and then group the second 2. Okay, okay, that was number 5, by the way, but we're going to go ahead and do number 5. I'm going to come back and do number 4. So that was number 5. So you're going to group the first 2 and the last 2. But remember, one of the things that you notice is that the GCF of those 4 terms is not 1. They all have x's in common, right? So the GCF is x. Now, what happens is that many of you forgot to factor out an x at the beginning, and that's fine. Okay, I'm going to show you how to remedy that in the end, but this is the way you should have done it. You should have first recognized the GCF is x. So that means I can factor out an x. Okay, so I get x times 4x cubed, because x times x cubed is x to the 4th, plus 5 times x squared, and then plus 4 times x, and then plus 5. All right, so because x times 5 is 5x, x times 4x is 4x squared. Now go off to the side and rewrite this part over, because you want to factor this part by grouping. All right, so you get 4x cubed plus 5x squared plus 4x plus 5. And so we're going to group the first 2 and the last 2. And so from the first group, I can factor out an x squared, and you get x squared times 4x plus 5. Remember, always factor out that middle sign here, plus, and then here, the GCF of 4x and 5 is 1. So it's plus 1 times 4x plus 5. And if you're doing this correctly, if this is factorable by grouping, then those two should be the same here, and they are. So again, that means you can factor out a 4x plus 5. So I get 4x plus 5 times, and then when you factor out this 4x plus 5 here, you're left with x squared. And then when you factor out the 4x plus 5 here, you're left with plus 1. So that goes here. So I get x times 4x plus 5 times x squared plus 1. Okay? So that will be the answer there. Now, this is what many of you did. Okay, so here's what a lot of you did, or a lot of you would do. Okay, because many students at the beginning of studying factoring, they tend to forget about the GCF. All right, and if you did, it's no big issue there. I'll show you how to fix that in the end. So let's do number 5 again. So here's number 5. We have 4x to the 4th plus 5x cubed plus 4x squared plus 5x. So let's suppose that you forgot about the GCF. And so you group the first two, you group the last two. And so from that first group, I can factor out an x cubed. Okay, so that's the GCF of that first group. So I get x cubed times 4x, because x cubed times 4x is 4x to the 4th, plus, and then x cubed times 5 gives me 5x cubed. In the second group, I can factor out a positive, in this case, x, right? Positive x. So I get x times 4x plus 5. Now again, notice that these two are the same, so that's the way it should be. So you factor that out. And so I get 4x plus 5 times x cubed plus x. Okay, that's where some of you stopped, but it's not correct, because remember, you got to factor completely. So every factor, you got to check and see, can I factor out anything here? Can I factor this further? So if you look at 4x plus 5, the GCF is 1. So you really can't do anything further with that. But here, I can factor out an x. So that means this right here is x times x squared plus 1. And so this, in number 5, this polynomial, you have 3 factors. And we always tend to put the binomial factor first at the beginning. See, that's a binomial, that's a binomial, we have this binomial. So let's put that first. You're going to say x times this binomial, 4x plus 5, times this binomial, x squared plus 1. So that's what you had to do there. So many of you forgot about this. So be careful that when you look at the next chapter dealing with rational expressions, you're going to need to remember this idea here. You have to factor completely. Factor completely. You got to make sure that all of your factors have been factored completely. This is not factored completely. I can factor out an x. All right, so that was number 5. So number 5, the answer is, for number 5, the answer is x times 4x plus 5 times x squared plus 1. Now let's look at number 4. So number 4, we had this in number 4. We had 3x squared minus 6xy minus 8x plus, and then 16. All right, so notice the GCF here is 1, okay? And so then we're going to group the first two, group the last two. That's what we tend to do. It doesn't always work that way. You may have to rearrange some terms here. But for us at this point, it's going to be the first group, the first two, and then the last two that you're going to group. So here, if you look at this, the GCF is a 3, and then I have x's in both of them, right? So I'm going to factor out just one factor of x. So I'm going to factor out a 3x, and so 3x times x is 3x squared minus, and then 3 times 2 is 6, and then x, I already factored out the x, so don't put an x here because you already factored that out. So you only had 1 here, you factor it out, but you do need a y. And so always check, 3x times a negative 2y gives us a negative 6xy. And then over here, you're going to factor out a negative 8, and then you get negative 8 times x is a negative 8x, and then negative 8 times a negative 2 is a positive 16. Let's see. I messed something up here. So let me go back and look at this. Oh, I'm sorry. That's supposed to be a y here. So that's 2y. I forgot to put a y here. So that's 2y. And I knew I messed up because these two are not the same. So now they are. See, that was a y right here. Okay, so now I can factor out an x minus 2y. So I get x minus 2y times, and then when you factor out the x minus 2y, you're left with 3x. And then x minus 2y, you factor that out, you're left with minus 8. And then again, always check, see, can you factor anything further out of here? So these are linear factors. All of the exponents are 1, so your x to the first, y to the first, x to the first. So the GCF of those two terms is 1, the GCF of those two terms is 1, and so you're done. That is the answer to number 4. So number 4, you get x minus 2y times 3x minus 8. Okay? All right. Now, number 6 says you want to factor each trinomial completely, and if the polynomial cannot be factored, you write the word prime. So if you look at letter A, so 6a, if you look at A, you have x squared plus x minus 72. Now, you got to remember, the first thing you got to do is look for the GCF, and the GCF of those three terms is 1. So we're good at that point. Now, at this point, what you would then do is try factoring as two binomials. And then we're going to use the idea of the reverse FOIL method. So we're going to use the idea of FOIL. Always do the f of FOIL first. So x times x gives me x squared. Okay. Now we go to the last. So you can do the idea of that last second. But remember, this is negative, so that means that one of these has to be positive, one has to be negative. And if it doesn't work, we'll try something else. So let's put the plus here and the minus there. All right. Now, give me two numbers whose product is 72, and then use your calculator. So some of you may say, well, 2, if I divide 72 by 2, I get 36. But obviously that's not going to work because if you do put 36 here and 2 there, remember you always want that middle term, and to get that middle term, you got to look at the outer and the inner. All right, so the outer is a negative 2x, the inner is a positive 36x, and when I add the outer and the inner, I get a negative 34x, and that's not what you wanted. So obviously, again, that would not be the one you would use. Okay, so you keep trying these things, and that's why we talked about that trial and error. You keep trying those things. So then you may say, all right, I'm going to try x times x is x squared plus and minus because the last sign's negative. So one has to be positive, one has to be negative. Let's try 9 and 8. 9 and 8. Okay, and let's see if that works. So using the idea of that FOIL. So x times x is x squared. A positive 9 times a negative 8 is a negative 72. And then the outer is a negative 8x. The inner is a positive 9x. And when I add them up, I get x, which is what I wanted. So that's your answer. So the answer to 6a is x plus 9 times x minus 8. So x plus 9 times x minus 8. So you factored. So in other words, when you factoring, you're rewriting your answer. See this trinomial that has 3 terms, you're rewriting it as a product of factors. And your factors are x plus 9, and the other one's x minus 8. So if you look at B, let's talk about B. So in B, you basically would do the same idea. Try some numbers and variables and see what happens. So in B, you have x squared minus 6x minus 27. And so, again, the GCF is 1. We're going to use the idea of the reverse FOIL to get us to the factors. So we're going to try factoring this as two binomials. Do the f of FOIL first. So that means x times x gives us x squared. So there's your the first term of each binomial. Now, again, notice the last sign's negative. So that means one's positive, one's negative. All right. And then you want to think of two factors whose product is a negative 27. So, for example, 9 times 3 is 27, right? 1 times 27 is 27, correct? And that's about it. So those are the two products that's 27. You always want to try the ones that's closest together on the number line. So 3 and 9 are closer together than 1 and 27. Doesn't always work that way, but always try that first. So let's go ahead and put the 9 here and the 3 here and see what happens. Now, a common mistake people make is that once they fill this out, they think they're done. You're not done. You got to make sure that what you wrote gives us this back. Okay, so in terms of FOIL, x times x is x squared, so that's correct here. The last, always go to the last next. A positive 9 times a negative 3 is a negative 27, so I'm good there. Now let's check the out and the inner. The outer is a negative 3x, the inner is a positive 9x, and when I add them up, I get 6x. But that's not what I wanted. I wanted a negative 6x. Well, all that means is this. See, this is almost the same as this, right? They're opposites. So all that means, since this and this are opposites, all that means is that I just got to change the signs in here. So instead of saying x plus 9, you're going to say x minus 9. Instead of saying x minus 3, you're going to say x plus 3. And then now notice it works. This is going to work because if you check it, look, the outer. The outer is 3x, the inner is a negative 9x, and when I add them up, I get negative 6x, which is what you wanted. Okay? So that's the answer to letter B. So I get x minus 9 times x plus 3. And again, the order does not matter, so someone else could have said x plus 3 times x minus 9. Someone else here could have said x minus 8 times x plus 9, because remember, multiplication is commutative. The order in which you multiply does not matter. Let's look at C. So in C, we have x squared plus 31x plus 32. All right, so we're going to notice that GCF is 1, so I'm going to go directly to the two binomials using the idea of that FOIL. And so I get x, and then notice the last sign's positive, right? So that means these signs in here are the same. They're either both positives, because a positive times a positive is a positive, or they're both negative. A negative times a negative is a positive. But you know which sign to use. You always use the middle sign because you want the outer and the inner to be positive, to add up to a positive term. So in order for that to happen, if the signs have to be the same, then in order to get this to be positive, they both have to be plus symbols. Okay, so let's try factors at 32. So you may say, well, 8 times 4 is 32. 2 times 16 is 32. 32 times 1 is 32. And that's about it. Okay? So again, let's try the numbers closer together, the number line first. So we're going to say 8 and 4. All right? So we have the F working, we have the L working. Now let's check the out and the inner. The outer is 4x, the inner is 8x. When I add them up, I get 12x, and that's not what I wanted. So that didn't work. So let's try 2 and 16 then. So 2 and 16. So I get x plus 2, x plus 16, right? But that won't work either because the outer is 16x, the inner is 2x, and when I add them up, I get 18x. And that's not what you wanted. And keep in mind, the first and the last are still good because x times x is x squared, 2 times 16 is 32. The only thing you have to worry about is the out and the inner. The outer and the inner have to give you that middle term. And then you may say, well, let's try 32 and 1. Okay, let's try 32 and 1. So I get x plus 32, x plus 1. But it doesn't work out because, look, the outer is x, the inner is 32x, and when I add them up, I get 33x, which is not what you wanted. So I've exhausted all possibilities. So what that means is that this is prime. So it cannot be, remember, prime means it cannot be factored. Okay, it cannot be factored. So in letter C, you're going to write the word prime. Okay, let's look at letter D. So in letter D, I have this for letter D. I have 4x squared minus 4x minus 24. So 4x squared minus 4x minus 24. Now again, the first thing you have to do is look for a GCF, and there is a GCF here. Okay, so I can factor out a 4. So when I factor out the 4, I get 4 times x squared minus x minus 6. And then all you do is look at this part here and go off to the side and see if you can factor that further. And you can, because look, so x times x is x squared. Now the last sign's negative, so that means one's positive, one's negative. So, and again, it doesn't matter if you put the subtraction here and the addition here, it does not matter, because multiplication will be commutative. Now we have 6, so the possibilities of 6 are 3 and 2, 6 and 1. You'll notice that what's going to work will be that this has to be 2, this has to be 3, this has to be 2. Positive 2, negative 3, and then check it. X times x is x squared. A positive 2 times a negative 3 is a negative 6. Remember, we're using FOIL. So the first of each term multiplied together is x squared. The last of each factor, each binomial, I should say, is when you multiply, will give you negative 6. 2 times negative 3 is negative 6. And then for the out and the inner, you have a negative 3x, a positive 2x, and you get a negative x when you add them up. And so the answer is going to be 4 times x plus 2 times x minus 3. Now, some of you may not have gotten this right away. You may have said, well, I'm going to try 6 and 1. Well, 6 and 1 would not have worked. When you fold it out, you'll notice it would not have worked. Okay? So that's the answer to letter D. So I have 4 times x minus 3 times x plus 2. Okay? And then now let's look at letter E. So E, I have 4x cubed plus 8x squared y minus 60xy squared. Okay, so let's find the GCF first. So if you notice 4, 8, and negative 60, I can factor out a 4. All right, so the GCF of this point will be a 4, because 4 goes into all these coefficients, and that's going to be the largest. In terms of the variables, I have 3 factors of x here, 2 here, 1 here, so I can factor out an x. And I cannot factor out a y. You cannot put any y's here because there are no y's in this first term. So that's your GCF. So I'm going to factor out a 4x. When I factor out a 4x, I get 4x times x squared is 4x cubed. And then plus 4x times 2xy, because 4 times 2 is 8. 8 times x times x is x squared. And then you have y. And then minus, and then here, that's going to be 15, minus 15, because 4 times 15 is 60. I've already factored out the x, so I'm going to leave a y squared there. Okay? Now, remember, you cannot say you're done. You got to look at this trinomial and see if you can factor this further. See if you can factor this trinomial further. And you notice that you can factor this further. X times x is x squared. The last sign's negative, so one's positive, one's negative. And then let's think about 15y squared. So the possibility would be 5y times 3y, right? And then 15y, and then 1y. So let's try this first. So let's go ahead and put 3y here, and then 5y here. All right, now be careful. Don't assume this is correct. So if you think about the FOIL, think about the reverse FOIL. So in terms of F, I'm good because x times x is x squared. In terms of L, I'm good as well because a positive y times a negative y is a negative 15y squared. But the problem, there's a problem here. If you look at the out and the inner, notice the outer. The outer, x times a negative 5y is a negative 5xy. And then the inner, 3y times x is a positive 3yx. But when I add them up, I get a negative 2xy. But what I wanted was a positive. Now remember in our discussion earlier, these are just opposites. So that means all I need to do is change the sign. So in other words, this trinomial, x squared plus 2xy minus 15y squared, I can factor that as x. Instead of saying x plus 3y, it will be x minus 3y times. And instead of saying x minus 5y, it will be x plus 5y. And now let's check it. The outer is x times 5y is 5xy. The inner, negative 3y times x is a negative 3xy. And when I add them up, a negative 3 and a positive 5 is 2, so you get 2xy. And that's what you wanted. So the answer then will be 4x times, and then these two factors, x minus 3y times x plus 5y. All right, and so that's the answer to letter E. So it'll be 4x times x plus 5y times x minus 3y. Okay? And again, remember, we always put the monomial factors first. So this right here, if you wanted to, you could have written your answer as 4 times and then just interchange these two. So you could have said x plus 2 times x minus 3. But always put the monomial factor first. You could have done the same thing here. Here you could have said 4x times x minus 3y times x plus 5y. Does not matter. Okay? The order in which you multiply is commutative. The order does not matter. So multiplication is commutative. Okay, so that is the key to the worksheet on factoring 1.